Okay, you guys, so we're going to do 10-6. Yes, I know you have. This is your warm-up. Again, if we were in school, obviously things are trimmed. All right, so we're going to do 10-6. We're going to talk about, all right, LA just for lateral area and surface area of cones today. Plus, we're going to talk about composite figures. And we actually already talked about composite figures when you guys did the areas in your other part. Okay, so we have our cone. Again, the most important thing, you have H, which is our height. We all know this is our radius, so we need that. And then, I'm not sure if you guys remember, we talked about this L also in the first day, so Monday's lesson, 1.8 of the Intro to Surface Area. I talked about what this little L stands for. This L stands for the slant height, and now it's going to come into play. If you're not sure, go look at your notes from Monday. All right, so again, we're only doing with right cones. You can have oblique or anything that's slanting. Don't worry about it. So I'm just going to tell you the lateral area. So your lateral area, again, is just the cone portion. Picture this like an ice cream cone. So it's just this outer portion here. And it's going to be pi r L. Be really careful. People tend to forget the L. And again, that's your slant height. And then the surface area, as always, we know surface area is lateral plus the base. Well, in this case, we all know we only have one base, so it's 1 pi r squared. That is your formula. That's all you really have to know, and then we're just going to go right into doing the problems. Okay, so make sure you guys have your formulas down. All right, so again, we all know first problem, really basic, so you guys understand it. So it says a right circular cone. If that throws you off, ignore the word right. It has a diameter of 6, so right away I'm going to put my 3. And altitude, please put your altitude here of 4. Find the lateral area and the surface area to the nearest square centimeter. Okay, so I'm going to write lateral area. Let's write our formula. I don't know what that was, but whatever. Pi r L. And then let's just write our surface area formula. So we have, pi r L plus pi r squared. So the biggest problem would be if we messed up our formulas. All right, so let's input our data. We got a pi, we got a 3. Here's what we don't have, the slant height. This is the slant height. But pretty easy to find because this is forming your 90-degree angle because this is your height / altitude. So you all should know you can do Pythagorean theorem. And I'll just write it in case we all forget. Or we should know our triple, which is 3, 4, 5. So if you guys put that in your calculator, because I want the nearest square centimeter, obviously this is 15 pi. And nearest square centimeter is a whole number. So when you put that in your calculator, you get about 47. Pretty simple. All right, then, pretty easy now. Fine, obviously, surface area is just working with both. I'm just going to put what we found here. So this was 15 pi, because this number here was rounded, and I don't want you to round yet, plus pi 3 squared. Okay, so now you just put all of that in your calculator, and you're going to get 75 centimeters squared. It's pretty simple. That's all you really have to do for a cone. All right, let's take a look at number 2. So Peter has a conical, can't really pronounce that right, lampshade. Again, this means it is a cone. So if you want a picture, I'm not really sure who has a lampshade like that, but it's going to work. So again, we have an altitude of 6 and a diameter, which means my radius is 6. Lateral area. Okay, so I'm going to write LA. Well, should write L or LA, it doesn't really matter. And write pi r L. So we have pi, we have the radius. What is our slant height, which is that? Well, you guys should recognize this really easily. 90 degrees, 6, 6, which means this is a 45, 45, 90 triangle. 1, 1, rad 2, so right away you should know that this is 6 rad 2. And for this problem, I'm going to say let's leave it as exact. So we just have 36 rad 2. Now, You can put the pi like this, however, you won't normally see it. It would be preferable if you put that. Think about you're multiplying. This is pi is a number in a way. So it's pi times 6. So really what it is 36 pi rad 2. Okay, number 3 is super similar. You're just doing Pythagorean theorem again. So we're just going to skip around just to kind of shorten our lesson. And let's go on to the back. All right, so we have a cone. It has a lateral area of 72 pi and a surface area. It wants us to find the radius. So you guys know whenever you're looking for like anything within the problem, you're working your way backwards. So they're talking about lateral and surface. Well, lateral is in surface, so let's write our surface area formula down. So the surface area is pi r L plus pi r squared. Again, it's of a cone. And then let's input our values. Surface area we know is 121 pi. Check. Lateral area is 72 pi. Okay, plus, and we got our pi r squared. Just like we did with our, what we do yesterday, our cylinder, we can divide all of these by pi. And you're left with 121 equals 72 plus r squared. All right, move this 72 over. You have 49 equals r squared, so your final answer for the radius is 7. Pretty simple. Okay, let's take a look at one more problem before we go on to our composite. So it says the lateral area is 120 if the base has a diameter. What is the length of the slant height? So again, pretty simple. Let's just working with your formula. Okay, so we have our lateral area. We know this is 120 pi equals pi diameter. So we have 12, and then we have an L. Okay, so we divide, and we get our slant height to be 10. Now, I can change this problem up, and I want to kind of do it with you guys. And instead, which would have made it a little bit trickier, I could have said, I'll do it in pen, my marker. I could have said, what is the radius? Nope, not what is the radius. I could have said, what is the altitude? And I'm hoping that you guys would have known that the altitude is not the same as your slant height. And you would have realized that, hey, if I want to find the altitude, you first have to find the slant height, because based on your lateral area formula, it's calculating the slant height. Now, once I have this, if you think about this logically, and if I drew the picture, you know your radius is 12. You know your slant height is 10, which something's not right with this problem, because I know that can't be larger. Let's pretend that I did not do that one. Which is ironic because I did not make this problem up. Moving on. Let's go on to composite figures. At least you have the idea. All right, we all know what a composite figure is, but these become a little bit harder only because you have to understand that when you're doing, you know, surface area, you have to, again, maybe write this down, wrap all surfaces. Think about like wrapping a present. I'm just going to write the word present. Think about if you have a present and you want to wrap it. You have to wrap everything. So you have to kind of use, not your imagination, but like a visual here to really figure this out. So we all know composite figures, you want to break up into like figures that we know and then find them. But again, it requires a little bit of thinking, and I do recommend you guys using like headings and like explaining what you're doing. All right. So if we take a look at this first one, you have a cylinder with a cone. Okay, well, if you think about this, let's do surface area of a cylinder. Let's explain it. Let's do one thing at a time. Well, for the cylinder, we know it's pi r squared h plus 2 pi r squared. However, think about this. This is open on top. So you're kind of, you want to cover in, but in is talking about the cone. So for this cylinder, you want to cover the whole lateral area plus one base. So I'll write it down so you guys have it. You want the lateral area plus 1 base because you have an opening on top. So for that, we have 2 pi r h plus pi r squared. So again, it's 1 base because you're not covering everything. And you need to make sure that's the biggest thing you have to make sure that you understand is, again, you have an opening. Okay, let's put our numbers in. So we have a 2, we have a pi. My radius is 6. My height is 18 plus pi radius 6. Okay, let's take a look at what we get when we calculate that. Okay, so we have 2 times 6 times 18 plus 36. So this whole thing is 252 pi. Let me just double check. 2 times 6 times 18 plus 36. Okay, so again, this is of, it's hard again to do it because it's not a 3D. Like I covered all of this outside and I covered the bottom. But you have a cone. And if you think about doing the cone, think about this logically. The cone surface area is lateral plus a base. This is open. So when you're covering, think like you're covering inside. You can kind of, I know it's hard, you can't really see my hands, but you're going inside the cone. So you're just covering this area of the cone. So we're just covering inside the cone, which is only the lateral area. So we only want your lateral of the cone because we have an opening at the top. And the lateral area of the cone is pi RL. Again, these become, like I said, a little bit more challenging. The radius is the same. And the nice thing with this problem is they actually gave you the slant height, which I shouldn't have because it would have made it a little bit more of a thinking problem where you would have had to find it. Okay, and then when you put this in the calculator, obviously you have 60 pi. And then I want you to take those two and you are adding them together because you want the total surface area. And when you add it together, here is your final answer. So please make sure, again, you guys understand that. The hardest part is understanding, you know, of the surface area, which pieces maybe that you don't want, which parts you want. Like, again, in the surface area of the cylinder, you didn't want a top. You only wanted 1 base. In the surface area for the cone, you didn't even want the base. So it's important that you guys understand it. You should talk yourself through the problems like I did and like label a title for yourself. Okay? All right, let's go on to our next one. All right, so if you look here, again, it's a little tricky. We have to think about this. We have a surface area. Let's talk about the bottom part. We'll say of a prism. I guess this is your rectangular prism. And then you have also a triangular prism. Well, if you guys go back to your notes for surface area of a prism, what did you guys have as your formula? No, I forgot. Your surface area of a prism's formula, so again, we should be reviewing, is the lateral area, so pH, perimeter times your height, plus 2 bases. But ding, 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 again, if you think about this, you do not have 2 bases. You only have 1 base because the triangular prism is on top of it. And if you think about, again, wrapping a present, you have 1 base, you're coming up the sides left and right, you're coming up the front and back, you're not covering the top. So again, we're going to take P times H. If you're not sure, go back to your notes, plus just 1 base. So that's the difference here. Okay, we have to make sure you understand what you're covering, so you have to think. All right, let's talk about what we have for the perimeter of the bottom. So for the perimeter of the base, obviously look at it visually. Where's your base? The bottom part. I'm going to do 8 plus 1.2 plus 8 plus 1.2. So the perimeter of my base, and again, if you forget your formula, go back and look at it, is 18.4. 8 and 8, 16, 17, 18.4. Okay, so what we're dealing with right now is just, I know it looks like it's hard to visualize it, but the base plus, times their height. Here is your height of the rectangular prism. So we have times 0.6 plus the area of one base, which is 8 times 1.2. So it's 9.6, right? 8 times 1.2. So then the surface area, we would take that plus 18.4 times 0.6. Here you guys go. This is your surface area of the rectangular prism. But we want to add the triangular prism. So we have the triangular prism. It's going to be a little harder. I probably should have left myself some more room. So here we go again with the triangular prism, which is a little bit more challenging. You're going to take the perimeter. Okay. Times your height. Right? But what you'd have to understand is the way we classify it as a triangular prism is not by the rectangles, but we're classifying it according to the face. So you're going to use, in this problem, I'm going to use that as my base because that's the perimeter. Remember, every prism is called based on the name. For a rectangular prism in this problem, it doesn't really matter which you choose to be your base, but whichever you choose to be your base, you need to be consistent and it needs to stay as that base. Okay? So we have perimeter times your height plus now how many bases do you have? Since I made that my base, I do actually have 2 bases. However, when you calculate this, it's calculating everything. So what you're going to have to make sure you're doing, and again, you can figure out other ways to do it, but you have to make sure that you then get rid of one of the rectangles and make sure you're getting rid of it correctly. Because if not, then you're over counting and you're kind of including an extra rectangle, right? Because you're not including, if you can kind of see, you don't want to include this rectangle on that triangular prism. Again, if you can try to make sense of it, think about it logically, think about it. All right, let's figure out what we have here. I'm going to just take that triangle out so you guys can see a little better. They mark these equal, so you have 1, 1, 1.2, 1.2. So it makes my life a little easier. Okay, so we have 1, 1, 2 plus 1, so 3.2 times. Now, the height of the prism is this. This is a good review for you guys. Remember, the height connects the 2 bases. So times 8 plus area of 2 of my bases. All right, so here we go again. It's a little harder. My bases are triangles, so I have 1/2. My base is 1.2. Yikes, we have to figure out our height. So come over to this problem. So half of 1.2, you guys should realize is 0.6. It's kind of ugly. And then we want to do Pythagorean theorem to find the height. Yes, the triangular ones are hard. So x squared plus 0.6 squared equals 1 squared. All right, let's have you guys calculate. I'm doing it at the same time. 1 squared is 1 minus 0.6 squared. 0.64, and when you guys square root that, you get 0.8. So x, which is my height, is 0.8. Look, and I'll even write it. Okay? Yes, this is one of your challenging problems, so you can put a little star here. You don't really get that many. So now I have base times my height of 0.8. Okay. Careful. You want, actually, let's just first calculate this. Let's just do one thing at a time. 3.2 times 8 plus, these can kind of cancel, plus 1.2 times 0.8. Okay, for this I get 26.56, but again, you have to remember this. Because what happens here, when you add these two, you're including the base of the triangular prism. So we want to get rid of that triangular prism's base. So the rectangle. Okay, that's pretty easy. So we want to minus, so it's this number plus this number minus. All right, so what's this base? We have an 8 here. And then this right here is 1.2. Oh, times 1.2. Sorry, can't really see that. So we have 8 times 1.2. So it's 9.6. So that's the area of that rectangle that we're going to get rid of. So in at the end, we add them up and minus that number. You guys should do it as well because I'm doing it now, which means you guys know it's a possibility I could make a mistake. This is what I get as my final answer. So please make sure you guys did that. It can be a little confusing. If you're like, I don't get it, let's try it one more time before we just do our last problem. So you have surface area again of the prism. So I basically found the whole surface area and I only included one base. I made this bottom 8 by 1.2 my base. You can make anything your base. So I did the perimeter times the height and then I added one base. Think about it. This is your lateral all the way around and then I got one base in there, check, and I got the information. Then for this one, the triangles are my base. Okay, I mean, you could change it for this one, but it's easier. So if you find the triangles, you have your perimeter, which we'd added all around. We found the height is the height of the prism, not the height of the triangle, plus the area of the triangle, which I showed you guys all the work up there. We had to find the height of the base, and we did that. However, you included this one rectangle here. I do not want this rectangle because it's on top of it. So I had to minus one of those rectangles out. Okay? Hopefully that makes sense. Those will be your harder problems. Here's our last problem, and then you guys are done for your lesson. Okay, so it says the total height of the tower is 10. All right, so we have 10. If 1 liter of paint will cover an area of 10 meters squared, how many 1 liters of paint are needed to paint the entire tower? All measurements are in meters. Find the total number. Okay, so we know that 1 liter covers 10 meters squared. We'll worry about that in a moment. So if you think about this as a tower. It's a tower, so it's on the ground. So if the tower's on the ground and you want to like paint it, you have a cylinder. Great. And then we have a cone. You have to think about this logically. When you're painting this cylinder, all you're painting is your lateral area. I'm writing LA for lateral area. Why? Because it's on the ground. We're going to make this on the ground so you can't paint underneath the tower. So we're just going to say it's on the ground and you only have that because that's not being covered. Then for your cone, again, you have no base there. So if you think about it, it's just your lateral area. All right, then let's take a look at our problem. We substitute our numbers in. So we have 2. I'm going to substitute the 3.14 in right now for your pi because it tells us so I don't forget. The radius is 4. The height is 7. Plus, we got our pi. The radius is 4. Slant height. So this is our slant height, if you guys remember. What's this value? Well, let's think about this. If this is 7 and the whole height is 10, the height of the cone is 3, and we can do Pythagorean theorem to get our 5. Okay? We put this all in the calculator. And you guys get this. Some of these I already had done, so it's faster. The ones I didn't have done, some of you might want to recheck me. So if this is the surface area of the tower and we still want to paint it, you obviously take this and we want to divide it by 10 to figure out how many cans. Well, when you do that, you obviously should get 23.8-ish. But if you want to figure out how many cans, 23 cans won't cover it. So you would want 24 cans. Okay? Oops, sorry. Hopefully that made sense. The only one that I thought maybe was challenging is the composite ones because you need to think. All right, you guys, hope everything's going well and you find the lessons helpful. Bye.